Hi, I'm Dick Glover, Technical Director, and this is where we work. We've been in McLaren Technology Centre since 2003, and under one roof we've got three world-class engineering companies: McLaren Racing, McLaren Electronics, and in the heart of the building, McLaren Automotive. We have a fantastic heritage of technology and engineering excellence within this building, and McLaren Automotive is able to draw on that heritage and all of that technology to develop the world's best high-performance sports cars. This is our Formula One simulator. We've been developing the simulator for the last 12 years, and it's now used extensively as part of the process within McLaren Racing. Before every Grand Prix, the drivers and engineers come to the simulator to develop the car and develop the race setup. We also use the simulator for developing the 12C and have done for many years. For more than a year before we ran the first test car, we were developing the vehicle dynamics in the simulator, and that's really put us in a great place at this stage in the programme.
Hi, I'm Chris Goodwin. I'm Chief Test Driver here at McLaren Automotive, and I'm at the heart of the 12C development programme and have been since the car was a drawing on a piece of paper. We're right in the middle of a very extensive test programme, and as you'd expect from a high-performance sports car, we're taking in all of the usual race tracks and test circuits. We've been to the racetrack, the Nürburgring Nordschleife, and that's a great test for the car's durability, but its high-speed cornering performance. The Top Gear circuit at Dunsfold is a favourite of ours. It's got its own unique challenges and is very close to our base here in Woking. But as well as an endless range of public roads, motorways, B roads, bumpy and smooth, we've also taken in a couple of very extreme areas as well. The Arctic Circle, we test the car in sub-zero temperatures on snow and ice, but we've also visited Bahrain and tested the car in super high temperatures, both for performance and its ability to function in those very extreme desert temperatures.
Hello, my name's Simon Andrew, Vehicle Development Engineer at McLaren Automotive. One of the most important things when we're road testing is the data that we retrieve from the vehicle. The key is to get this data out of the car as quickly as possible. Then we send it back to the McLaren Technology Centre where the engineers there can analyse the data to see how the car is running, and then we can make improvements and tune systems based on the data that they're looking at.
This is a very, very high-tech car with some interesting technology under the skin, and I work with a team of very experienced guys, and they come from many different backgrounds, many from the world of motor racing. That's an experience that we try to have going throughout the company here.
It was a very big decision for me to leave racing and join a road car project, but there are many similarities, and it's very exciting and challenging to be involved in a performance road car project.
To complement that, we have a number of engineers and technicians from mainstream automotive.
You sometimes have to step back and to realise how lucky you are. It's an awesome job, it's great fun.
The 12C is a great opportunity for us here at McLaren, starting with a clean sheet of paper and a list of no compromise objectives and targets. It's been a huge mountain of work, but McLaren's way of doing things, harnessing the very latest technology, focusing on amazing attention to detail, will produce a market-leading car in this segment.
McLaren Automotive's engineering and development team has been testing and developing the latest phase of prototypes at one of Europe's leading proving grounds for the last 5 weeks. This latest generation of vehicles that we've taken, experimental prototypes, what we like to call our XP beta vehicles, reflect the very latest state of development for the program. Previous XP vehicles have been built to test individual systems in isolation. But with our XP betas, this is the first time those technologies and systems come together to reflect what we'll see in a true production vehicle. Some supercars that you drive are pretty intimidating. That's something with the MP4-12C that we've never really wanted. And I'm very pleased to be able to say the progress that we've made, again in this aspect, we're delivering bang on target. You can get in the car and within 100 metres feel inspired to drive the car, which is great. Everything we're trying to do with the car is to make the car as easy as possible to drive. So all the controls need to come at hand very easily. All the primary surfaces are ergonomically positioned to make them intuitive and obvious. Similarly with the sightlines, we wanted exterior visibility of the car, of the road, to be extremely good. Whether you're driving on the road or on the track, being able to see apexes of corners is extremely important in a high-performance sports car. From the very onset, it's been extremely important for us for the car to achieve its very highest levels of performance and efficiency, to put it at the very forefront of the sports car market. And I'm really pleased to be able to say that the ride, the handling, the steering, the brakes are all really, really very good and will require only minor tuning between now and the end of the programme.
The big early steps of development are challenging, interesting, relying very much on simulation, relying on a huge amount of research. But now we're at a stage where we've made those great strides and we're trying to make everything fit. And that's why we're here in Idiada, trying to integrate all of those systems and attributes of the car. So the gearbox, the engine, the tuning and calibration of those, the chassis, the aerodynamics, everything is now meshing, and it's where the attention to detail really does become intense. Testing the XP Beta cars here in Idiada mirrors what we do in Formula One testing, certainly in its intensity. In fact, it may even surpass it. We're running 24/7. In that respect, it's a very intense but very productive test program. I am passionate about this car. I do love driving it. The team we have here at McLaren has been able to create some fantastic opportunities that the technology has allowed, and that is to have something that's slow and comfortable and easy to drive, but at the same time, literally with the turn of a switch, engaging all of the technology under the skin here, we get a taut, fast race car. It's one of the fastest road cars that you can possibly get your hands on. It's awesome on a racetrack, and normally you can't have the two things, but with this car we do. Today we've brought two of our XP Beta prototype test cars to Goodwood, but we've also brought Jensen and Lewis along to have a drive. It's their first exposure to our work. At McLaren we're very fortunate to be able to draw on a huge amount of Formula One expertise and technology, but also with Lewis and Jensen we've got two world champions helping with our test programme. It can't get better than that.
Let's do it. The sound of the engines. went through, yeah. He's flat out, he's not supposed to drive 100%, but we don't know how to drive anything less.
I think the biggest problem with this car is you do forget sometimes it is a road car. You're braking good. My turn. And there's one corner out the back, which is the left, which you don't even need to push, and you can feel the grip of the car, and the shift's good. And if you get the power in a certain rev band, I think it's about 6 to 7, it's got this sound. It's
yeah. Nice. It sounds pretty cool when it goes past, man.
First of all, you've got to remember, you've got to take your racing brain out, really, and put it to one side and remember that it is a road car. So it's a nice car to drive, and it feels very quick as well.
The great thing with this car is the engine and also the downshifts. I feel really comfortable. You hear the turbos kicking in. Very good. You can brake very late and deep. It's very responsive, you know. Change the direction.
I have been involved with this project from the beginning, and when you're passionate about it and then you see someone come along and drive it quite quickly, yeah, it's an interesting feeling, but you know, we've got to get used to it because we're going to sell a lot of these cars and have to get used to handing them over to owners and they can do what they want with them.
Sounds good.
Take it.
Today we're here to share with you what our vision looks like for the future. Our vision embraces not just a car but a whole car company. Everything we are doing is going to be pure McLaren. We will set new standards for quality, performance, efficiency and the ownership experience. It's inspired by Formula One and rich in McLaren DNA.
Years ago, the board of McLaren presented us with what is an absolutely irresistible challenge: to create the best new sports car company. Our right to exist is based on the fact that we needed to find a way to exceed our competitors in every way, in the performance of the car, in the quality of the car, in the quality of the ownership experience, and in this way we'll give our customers a real reason to buy a McLaren. We needed to take technology and push it not just to the edge of what's possible, but to the very edge of what's possible. Everything about the MP4-12C, the production system, the retail network, and the way we take care of our customers has been redefined. We like to refer to the 12C as an "and" car. It has the highest performance and is the most efficient car in its segment. It has incredible handling and is remarkably comfortable to drive. It's compact on the outside and hugely spacious on the inside. And it's the lightest car in its segment and amongst the safest and best equipped. The basic concept comes from Formula One principles. It starts with a driver, and the driver sits in a rigid carbon fiber safety cell, our monocell. And lightness is what this car is all about. Everything in it is light and compact. But this lightness has not come at the expense of safety. Note how not just the monocell, but even the windscreen remains undeformed, undamaged, and not even cracked. The M838T is a state-of-the-art turbocharged, downsized 3.8-liter V8 twin-turbo engine, which combines a true racing DNA with road car principles and drivability. It's a seamless shift dual-clutch gearbox, which is also very light and very compact. The chassis control is just as sophisticated as the drivetrain. The driver can choose between 3 different handling modes, which vary the damper stiffness and the stability control. The handling performance of the car is also enhanced by brake steer, which is another Formula One derived technology. Another advanced technology is the air brake. But the 12C's technology is not just focused on vehicle dynamics. And so we've developed our bespoke Iris system, which we believe is the ultimate in-car information system. We've had the opportunity to revisit sports car manufacture with a clean sheet of paper. We have a new sports car, the MP4-12C. It's designed with state-of-the-art, all-new components and technologies. It's been developed using a unique Formula One-inspired testing program. It'll be built in a purpose-designed, brand-new production facility. And it will be sold through a global distribution network with an absolute passion for customer service. Everything about the car and the experience is pure McLaren. It's authentic. It is the real deal. We decided to choose 2 of our confirmed customers to give us their feedback and to make sure we were on the right track. Let's hear what they have to say.
The car actually handles like a real car should handle.
You get to a corner and you're picking up very, very good grip, and it's got the racing car pedigree, and as it should do, it's built under the same roof as our racing car.
Well, the power, it's got great power. It's very smooth, but the gear shifts is a bit like our Formula One car. It's got the same click, and the reaction time is just great.
Today, we've added a truly exciting new car brand to the world, McLaren Automotive.
Years ago, the board of McLaren presented us with what is an absolutely irresistible challenge: to create the best new sports car company. Our right to exist is based on the fact that we needed to find a way to exceed our competitors in every way: in the performance of the car, in the quality of the car, in the quality of the ownership experience, and in this way we'll give our customers a real reason to buy a McLaren. We needed to take technology and push it not just to the edge of what's possible, but to the very edge of what's possible. Everything about the MP4-12C, the production system, the retail network, and the way we take care of our customers has been redefined. The first result of this process is the 12C. We like to refer to the 12C as an and car.
McLaren, we are passionate about what we do. Today we're here to share with you what our vision looks like for the future. Our vision embraces not just a car, but a whole car company. Everything we are doing is going to be pure McLaren. If we hit our targets, we will deliver on our own aspirations. We will set new standards for quality, performance, efficiency, and the ownership experience. The 12C that we're about to reveal to you is only the first in our range of high-performance sports cars. It's inspired by Formula One, built with the pride and passion to the highest quality and rich in McLaren DNA. Today, we've added a truly exciting new car brand to the world, McLaren Automotive. Now, I'll ask Lewis and Jensen to give what is for many of you the first sight of a complete 12C. It is our traditional launch prototype colour of orange. If you go back in history, this was how we always launched our cars. But of course, there's an incredible range of colours, and this is merely one of them. Thank you, guys.
To go with it, or?
Dan, please unveil the car.
Cool.
Lewis, if I could ask you to just come to the front, and Jensen on the far side, just to the front as well, please, just for some photographs.
You get to a corner and you're picking up very, very good grip, and it's got the racing car pedigree, and as it should do, it's built under the same roof as our racing cars.
Well, the power, it's got great power. It's very smooth, but the gear shifts It's a bit like our Formula 1 car, you know, it's got the same click, and the reaction time is just great. The car actually handles like a real car should handle.
I think you're gonna like mine.
Mine's sort of it's not a love-hate relationship with mine. I think people are just gonna like it, but with yours, I think it's sort of, you either think it's awesome.
I like it to be like,
yeah, that's what you want.
that looks wicked.
This is so cool.
Getting ready for the next interview.
Launching the McLaren MP4-12C at Pebble Beach is absolutely appropriate. This is a place that's a celebration of groundbreaking cars, cars that have endured 50, 60, 70 years and are still beautiful and still demonstrate their purity and their heritage even today in 2010. And the 12C is a car that we hope will one day, 40, 50 years from now, perhaps grace the 18th fairway at Pebble Beach. There's so much depth to the 12C, so much technological innovation, things that are really truly interesting and different from competitor cars. And so the reaction from the customers has been really amazing. They really understand it, they get it. We've had probably 200, 300, 400 people come here on almost one-on-one private tours of the car. They've seen the rolling chassis, they've seen the car behind me, and they understand how this car is fundamentally different from what else is out there in the market. They understand the heritage of McLaren from Formula 1, Indianapolis, Can-Am, Le Mans. They understand the innovation that the 12C represents, and they understand the purity of purpose that's inherent in the 12C. It's been really great, and really happy to see people understanding what we've been setting out to do. Well, a lot of people have asked us whether it's relevant for McLaren to launch another sports car into the North American car market, but we feel very strongly that the MP4-12C is not another sports car. It's something that's very, very different. It uses different technology, and it uses that technology to offer fundamentally better performance. We have to, as a new brand, astound customers. We have to offer them things that they cannot otherwise purchase. And the MP4-12C, whether it's its carbon monocell or its 3.8-liter 600 horsepower engine, its proactive chassis control, the whole overall conception of the car, the Formula 1 testing regime, it offers something that is truly different and, importantly, is truly better. This is a car that offers a performance envelope that's far beyond what any other competitor offers, and as such we're able to make a car that's not just another sports car but truly pushes the envelope farther to the edge of what's possible. The 12C has the basis to be a success in the North American market for a number of reasons. First and foremost is McLaren has a terrific heritage. As many people know, we've won 20 Formula 1 Constructors and Drivers Championships. 1 out of every 4 races we've competed in Formula 1, we've won, and we've come up at the top of the podium. And this incredible heritage, though, is not a heritage that comes by chance. It's a heritage that's driven by innovation, innovation, and innovation. And as a forward-thinking company, we're taking this innovation and pushing it into the future. McLaren has the heritage, but we're a company that looks always forward into the future. The 12C has 2 aspects which make it very, very different from what we think a lot of other cars have in the market. First of all, the extreme innovation which comes from Formula 1, which allows us to offer greater performance. And secondly, a purity of thought, a consistency in the car. Every single part of the 12C is designed specifically for the 12C, which has allowed us to design a very coherent car, a car where every dynamic input is balanced and matched with itself, a car that's as light as possible, a car that one day people will look back and say that is a heritage on which I can base another step into the future. The reaction to the 12C has been just great. We've shown the car here in our private hospitality. We have it up on the concept lawn. We had it at the preview of the Gooding auction, where coincidentally there was chassis number 62 of McLaren F1 on auction there. And people have heard a lot about the 12C beforehand, and they've read up on it. And there was a lot of anticipation about what the car would be like. And to see people's faces as they now see the car for the first time in real life, in detail, they see the technology that's in the carbon fiber chassis, and their eyes start to light up, and they really get what we've been trying to do. By the time they've been immersed in the 12C experience, they come out with wide-eyed, saying, I really want to have one of these cars, what do I need to do? It's been just a fantastic reaction. The enthusiasm is fantastic. Our North American office is based in Midtown Manhattan in New York. We've set up dealerships in Greenwich, Connecticut, in Tampa, Miami, Philadelphia is coming, Chicago, Toronto, Dallas, San Francisco, Beverly Hills, and Newport Beach will be announced shortly.
We have a huge opportunity here because we're launching a car company from scratch, so we can do things the right way. And we feel we have the right people, the right mentality, the right structure. We want to do things differently. We want to reinvent the wheel. We want to provide a different level of relationship between the dealer and the manufacturer. We feel we've come up with the best dealers to represent McLaren in their individual marketplaces. And we're very excited about the dealers that we'll be working with, and the dealers are very excited about working with us. At Pebble Beach, we had our very first dealer meeting, and the dealers have been raving about it since. I think the car is fantastic. I mean, I love the styling of the car. I love the fact the car was built from the inside out for the driver, and I love the car is for everything. It's a performance car and a luxury car. In a lot of ways it does. It reinvents the wheel in this segment. From the company standpoint, for the exact same reasons, the company reinvents the wheel in the way that they want to handle prospects and customers and transparency and the dealer network and the way that we want to conduct business. And I think that the car speaks in volumes about the company. Our dealers are committed to a much higher level of transparency and customer satisfaction, and I think that the customers and prospects in this segment are going to be overwhelmed. McLaren has a history and a heritage of being the best of the best, and I don't think this will be any different.
We've come here to Portimao to launch the McLaren MP4-12C road car to the world media. The circuit here is an amazing combination of massive elevation changes, some very tight corners and some very fast ones, and it allows us to really demonstrate what this car is all about. We have mechanics, we have electrical engineers, we have vehicle dynamics engineers, the full team of people that have produced and developed this car. They're on hand to make sure that the cars run faultlessly, but also so that they're on hand to answer any questions that the media have.
It's been a long time coming, but the McLaren MP4-12C is finally here.
Si chiama MP4-12C. È un'auto davvero straordinaria.
It has some pretty staggering numbers associated with it.
It's impressive the way that the car handles.
Doesn't it? It does. And the great thing is, when I brake, I know I'm doing it. You know what I mean? It's not all about the ABS. any other car and I can just throw it in there. It's just awesome. Yeah, this is a proper road car. It's a good car.
We're here today for the very first running of the 12C GT3 car. It's a very exciting day. This is a very exciting project. It's the first racing car to come out of our road car division since the F1 GTR back in the 90s. That was the last McLaren I raced, and this will be the next one. The combined team behind me from CRS and McLaren have taken the very best from the 12C road car and put it into a racing variant, and it's the car you see behind me right now. A very good looking car, and they often say if a car goes as well as it looks, it's going to be a quick car. This looks very fast.
Well, it was a gamble, yeah. But the thinking behind it was that at the time, ground effect, which is was created by the tunnels underneath the car, was key to performance. I mean, the aerodynamic benefit from them was huge. So you wanted to make those tunnels as big as you could. That meant making the chassis as small as you could. You make the chassis smaller, you lose stiffness. You lose torsional stiffness, bending stiffness, and so on. So the next thought process I had was, how do I get that stiffness back? Logically, I need a better material. I need another material. That meant finding something, and I was lucky enough to get talking to someone at British Aerospace that were then at Weybridge, and talking about material, because carbon had been, there were little tiny dabs of carbon used in racing up to that time. People had used strips of it to stiffen end plates on wings and so on. I think it was a Brabham with just a single panel of flat carbon replacing an aluminium panel, things like this. So the term carbon fibre had been around. Nobody had really discussed it in terms of, taking it any further. But once I got talking about it, I realised that, here's a material that you can tailor to your needs. And obviously, I think what people have to realise is carbon is very unlike metal in that when you're laying up a carbon structure, you can apply more or less carbon in certain areas to cater for load cases and so on. And that means you can tailor the material to the job, thereby saving weight, thereby improving performance. And so, you know, it's like all these things, once you start looking at it, once you get into it, you realise there are more benefits than you first thought of.
You know that now, but when you were first drawing up the designs for the car, you're working with something you had no experience of. So how did you get from the idea of, okay, this will help me make a slimmer, more aerodynamic car, to actually I've got to go and build it? Because there wasn't a lot of expertise around. How do you?
You start on the drawing board basically, and you just stand there and stare at the drawing board until you think of what to draw. But I mean, you know, I suppose the reality is that the shapes of the original monocoque. First of all, we're in an age when there was 5-axis machining was not available. I mean, there might have been one or two major aircraft companies that did it, but it was not available. So things you couldn't think about making the actual bodywork from carbon like it is now. You know, the monocoque could not be the aerodynamic surface because we didn't have the facility to machine those sort of mold tools. And you've got an aluminium monocoque in your mind in terms of shape, but then I'm changing that shape because I want the monocoque smaller, and it's just a process. The trick was, or the problem was, that with the composites and with the composite sandwich, you've only got one face, which is a known face. In other words, you've got a mould either inside or outside. In this case, it was an internal mould, male mould as we call it, and that gave me a face on the inside to attach things to. Now, if you're attaching wishbone suspension and so on, it's not the most convenient place to have a nice known face on the inside of the monocoque. So, you know, the process of how you design around that is very different from metal. And so immediately you've got to start throwing away your metal thinking and thinking about, okay, how do I achieve my fixing points on the monocoque? Because the outside of the monocoque, if anybody took the bodywork off of that, is a fairly rough structure. It's what we call a bagged surface. In other words, it's where the bag that compresses all the material while it's being heat cured leaves a fairly rough surface. So you haven't got known surfaces. And all that process of design was fundamentally different to metal. But, you know, you think of solutions as you're going along.
How did you actually get it built? Because if there weren't people in the UK, the industrial development had stalled. So you had to go on a bit of a journey, didn't you, to actually get it made?
Yes, I mean, Ron and I went, once I'd got the basic design, Ron and I started to approach one or two companies in the UK that were known to be doing carbon. I mean, there were companies making helicopter blades and things like this. And we took the drawings along, and well, in some cases we didn't actually get out of the foyer, but we got, generally speaking, the attitude was, it's way too ambitious. You know, who are you? There's a half a dozen, well, I mean, there was literally two of us. There was myself and an assistant doing all the drawings, getting all the mould tools made. Ron was rushing around trying to finance the thing, and so when we went to see a lot of these people, they said, look, we just think it's way too ambitious, and, you know, we don't want to be involved. I got a connection to Hercules in Salt Lake City through a friend chap I'd known in America when I worked on racing there. And he put me in touch with the head of their R&D section, which was not terribly big section, but I hate to say it, but the attitude was just 180 degrees. I mean, it was like, hey, you know, racing car, gee, that's kind of interesting. We've never done one of those before.
What were they making
they built rocket motors and rocket engines, intercontinental ballistic missile engines and things like this. But they were into carbon composites. They had started to get into carbon composites, and they'd set up this R&D division, and they just thought this is the project they need to take them forward. So they agreed to build the first chassis, basically, you know, off their own, for free, basically. We produced all the tooling, gave them all the designs, gave them all the layout for the composites, and then they laid up and cured the first ones. Eventually, we took that back into McLaren, but yeah, I mean, it was an attitude thing, really.
And when you started working with it, you know, you get the first one off the drawing board, you're actually racing the car or testing it. What did you discover? I mean, you were learning presumably on the job, having to learn really quickly.
Yeah.
What did you discover about carbon fibre that you perhaps didn't know when you were first doing those early sketches?
Well, I mean, the first one was a result of hand calculations. At the time, again, you know, you can see how far back this is. Hercules, who had a Nastran finite element program, which was in its early days, and they said, oh, we'd like to do an FE on this monocoque. I said, yeah, fine, you know, here's the drawings, you know, you go ahead. I think by the time they'd finished the first FE, I think the car had been on the track and already run, so that was just showed you how long it took them to do what today you can do probably in a day. You know, it's a day's work. Then it was like 3 or 4 months.
And did it perform as you expected? Were there any surprises, you know, after a couple of races, thinking, do you know, it's better than I thought, or not doing what I expected?
Well, the very first chassis was built on the conservative side. We took the first chassis back to the factory and built a simple torsion test rig, which we torsion tested the first chassis and realised, I said, well, it's actually stiffer than I anticipated. It was a good 2.5 times stiffer than an aluminium chassis, a similar aluminium chassis of that period. So I said, but it was a little bit heavier than I hadn't saved as much weight as I wanted to. So I said, okay, the second one I'm going to take some material out, which is another thing you can do with carbon composites, is you can tailor your layup. So we took material out of the second chassis, which made it substantially lighter and dropped the stiffness a bit, but we were still sort of nearly twice what an aluminium chassis was. So that was the learning process on the chassis. I think it's fair to say when it became knowledge that we were doing this carbon chassis F1 car, there were a lot of people out there who were saying, oh, it'll be a disaster, mechanics will be dropping spanners on it and all the carbon will crack when they drop a spanner on it, and if a driver has a big accident, you know, it's just going to be a cloud of black dust, etc., etc. This was being around and being talked about, and I mean, I'm sure when John got in the car, I would imagine there were thoughts like that going around in the back of his head.
We'll ask him.
But you know, that's what you're facing when you're doing something new, and it's, you know, well, I mean, it proved itself as a racing car in fairly short space of time. I remember in '81, I think it was John got third, second, and then first at Silverstone. So it was working. People couldn't deny that. There's the result. Yeah. What really sealed it then was the big accident that John had at Monza, when he went off the road, and it looked horrific. I mean, the engine was smashed off the back of the monocoque, the gearbox broke, there was an oil fire, we just looked on TV and thought, oh dear, you know, this is it. And he stepped out, you know, stepped out of the monocoque, sort of looked at it as much as to say, oh, what have I done?
Did you ask him what he'd done to the car?
He could see what he did to the car, yeah. That was pretty much written off. Well, in fact, I don't think the chassis was written off. I think we actually repaired that chassis. Well, it's nice to be in this position of talking about, you know, the first carbon monocoque F1 car. What I've always asked along the way, along this last 30 years, is it going to come in road cars? You know, when are we, and my answer is going to be, yes, it will come in road cars. It must come in road cars because you need to save weight. I mean, everybody's trying to make them more efficient. One way is to save weight. And, you know, carbon to me is the obvious way to do that. So I'm surprised it hasn't come sooner, at the top end. I mean, obviously carbon is an expensive material to use at the moment, but with technology like this and well, increased production of carbon, that's another problem, because now that the aircraft industry have really embraced it, you've actually got a world shortage of supply, or not a shortage, but a difficulty in supplying as much as is needed. But once that gets fixed, then I can't see any reason why it can't filter down into the lower end road cars, and I've said that for years.
I think initially I never thought of myself as being a test pilot. And therefore my Chuck Yeager moment, which Chuck Yeager was the first man to break the sound barrier, was stepping into MP4-1. And John's explained it in a way which I sort of had insight to prior to getting into the car, partly because I'd seen the process, the construction of the tub, and again John's explained that. And also the involvement with Hercules, because they were producing these booster rockets for the aerospace program. And you may notice when, I mean, take the shuttle for example, you see that when the shuttle I think gets out of the atmosphere, then these two rockets spew off on the other side. Well, they then are parachuted down, and usually they land on water, in water. They're then taken back to, in those days Hercules, recycled and sent back again to go on to the next flight. So the material in those areas manufactured by that company worked, and they were recyclable. Whereas previously in Formula One, carbon fiber had been used, but it had been used as a metal substitute, not as a product, as a material in its own right, and it wasn't being designed the way it needed to be designed. It was designed simply, well, there's an aluminium panel there, let's put this new material, carbon, on, get the pop rivet gun and go pop, 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 pop. And as soon as anything happened in those cars, they just literally did go to dust. That isn't the case with MP4-1. It was a car designed, as John has explained. And when I got into the car here 30 years or whatever number of years ago it was, for sure it was a new technology, and I was the first driver to experience a full competitive Formula One car built of a material that wasn't metal. And the history of motorsport has been a history of metal, be it steel, aluminium, titanium, in some cases even maybe something like beryllium. And here was a car, the chassis of which was, some people have called it plastic. It wasn't. It was a very sophisticated material, but the key to the material was in how it was used. And the misuse of the material was wrong, and it led to some drivers getting injuries. In the case of MP4-1, it was used as John has intended, as he explained, and it was a complex process, and he was sort of, in a way, pioneering the techniques of the technology. And we ended up with MP4-1 and referred to my big accident. In fact, it wasn't that big. It's just that it was the biggest of all the accidents that we had in 1981. My teammate Andrea De Cesaris, a young Italian driver, had 17 accidents. I'd only one, but Andrea had 17. But my one was the one that people remember because it was a big, spectacular accident caught on television. And basically what happened was I was following a couple of cars through a corner called Lesmo 2 at Monza. Sadly, a mere shadow of its former self, but a very quick corner in that particular period. And I wanted to pass the cars. I was quicker than the cars I was behind. I knew if I could get myself into position going into the Ascari chicane, I could get a shot down the inside and the momentum slipstream and pass down the inside. Anyway, that was the idea. And came out of Lesmo, and I felt the car running slightly wide too early in the exit. And ordinarily, you'd just check it in the throttle to bring the car back into line. I thought, this time, no, I'm going to drive it through the corner. I know I'm going to run the curb, but I want to maintain the momentum. But got the left-hand wheels on the curb, and they slipped off, so the curb then actually hit the bottom of the chassis, and the bottom of the chassis was just doing this, and eventually it sort of started to pivot, and it began this long, sort of, apparently to me, long, slow looping spin, and the car went from left to right, and spun backwards into the Armco barrier at a point where there was a fence post. So the gearbox penetrated the layers of barrier, then got levered by the fence post, which pulled the gearbox off, and then the engine and the rear suspension. I'm sitting in the car thinking, I'll not say quite what I thought, but I'm going to hit the barrier. And there's a bang, opened my eyes, looked around, and I saw an engine. I didn't know whose engine it was. I thought it was somebody else's. I saw an engine sliding across the track. And Michele Alboreto, who was a few seconds behind me, sort of had a closing gap, and he didn't quite get through. So he was taken out by the engine. Turned out to be my car. So when I got out of the car, I walked around the back, and that was my engine. Gearbox was stuck in the barrier. Even the gear lever, the gear lever in the car, it had vanished. It had been ripped out along with the gearbox. Now, I hadn't seen what everybody in the pits had seen or people at home had seen, which was this flash flower, which was just basically oil vapor. So I got back to the pits in the back of a motorbike and walked in. Sorry, guys, big shunt. People were shocked because they thought that it had been a much more serious accident. And the fact was, I didn't have any injury whatsoever. I had a slightly stiff neck the following day. I hadn't seen the incident. I saw it later that night on television. Didn't mean anything to me. It still doesn't really mean very much to me because it wasn't that big a shunt. Backward shunts are the best to have because there's a lot of energy there to dissipate the force of the accident. I just got out of the car, thought, oh, sorry, guys. Ron's going to be unhappy. He'll probably have something to say. John will be furious. Where are you, John? Yes, he was furious. But the car had worked. It had done what it was designed to do, and that was effectively the bits that are going to absorb all the energy in an impact dissipated. The tub, in fact, was virtually undamaged other than where the engine mounts had been ripped out. I had no injury other than just a very slight sort of stiffness of the shoulders because I hit the barrier backwards at probably about 80 or 90 miles an hour, which is not something I would advise you to do. And I think the big result was that because of the integrity of the design and the structure itself, had that accident occurred in a traditional aluminium and steel car, I don't know whether the reaction of the tub, an aluminium tub, would have been as inherently strong as it was with this tub, because aluminium will always break or bend or whatever. So the possibility was maybe you might have had a serious fire, which was an issue in cars at that time, or you might have had the tub where the section changes occur, where the cockpit ends and the seat tank begins. You could have had a spinal injury. I just walked out of the car, didn't know really what the fuss was about when I got back to the pit. Sorry, guys, as I said. Then I saw it later. But the car fulfilled my requirements in a situation where I was having an accident, and obviously clearly a big accident. Oh. Well, I reckon, first of all, it's mind-bogglingly quick. To me, as a road car, literally the first time down the little straight that you were driving on later on, it's massively quick. By a million miles, the quickest road car I've ever driven. And I was surprised. I hadn't anticipated that level of performance. It is seriously quick. But the thing that was impressive is that the bit between, say, 80 miles an hour and 130 miles an hour, I would say is not a lot different to this car. It is so quick. And then the car, you get to a corner, the brakes work. And normally when you put a road car, a high-performance road car, or any road car on a racetrack, you immediately have shortcomings, primarily because the car isn't intended to be a racetrack car. It's a road car. You turn the wheel and the car follows the wheel. It turns into the corner in a way you'd expect a race car to do. And of course, the suspension and the way the suspension operates is a very sophisticated, no roll bar system. And you've got infinite amount of adjust. I kept the car actually on its road settings because I wanted to find out about the car just as it would be on the road. I can't imagine what it's like when you get into the more advanced settings for track running or whatever. It's amazing. I was truly gobsmacked with the performance. It was something I hadn't anticipated. I knew it would be impressive, but not to the level. I was really surprised. I think at the time we probably didn't quite realize because we were looking at winning races, trying to win maybe a world championship. But I think one of the moments that clearly was very important for everybody in this project, for Ron and for John, for myself and for Marlboro who supported it, was it was a totally different direction in terms of technology breakthrough. And you look now at motorsport, motorsport exists only, well, you couldn't have the kind of cars we have today without carbon fiber because you couldn't get the integrity of the car that you need today with metal. If you did, it would weigh a ton. But coming here to the British Grand Prix in '81 And winning that Grand Prix was very special. It was very special for a variety of reasons. First of all, it was the first time a carbon fiber chassis car had won a Grand Prix, and it validated, you know, John's commitment to the product and Ron's commitment to, you know, ensuring that John had the funding and all that had to go with that to enable it to happen. And you know, it was a small part in the story of the history of carbon fiber in motorsport, let alone in, I mean, just think about in the aircraft industry now. You're explaining with the Dreamliner from Boeing, with the Airbus, other areas in the military field where the material is now becoming, they have to use something to provide the strength but the lightness to enable these fighter planes or whichever they may be. Your stunt plane you were telling me about the other day, what you can do with a stunt plane. It's the only material, to my knowledge, that has got the strength with the weight saving, and we were a part of that very early process. I didn't think about it. It's more reflective now that you mention it, but very proud to have been in that role in the first days of carbon fiber in Formula One.